Previously, in the first part of this section, we tried to solve the problem static range sum queries from the online judge CSES by using a naive approach. So we get a time limit exceeded as a result here. Why this? Because the time complexity of this function, range query naive, is big O(n). So the whole time complexity of the code will be big O Q times n, where Q is the number of queries and n is the size of the input array. We see the result here. This is the size of the array, and this is the number of queries. As you see, there are big numbers. That's why our code exceed the time limit of the task here, which is 1 second. Can we improve this? Of course, the answer is yes. We can use different approaches. Don't forget, we deal with the static range, which means that there are no updates in the original array. So just we want to know the query, the sum between two bounds. We can use different approaches like dynamic programming, square decomposition, sparse table. But guys, to keep the thing simple here, we're going to use the most simple one here, the simplest one, which is the prefix sum array. The time complexity of just one query is big O(1), it's in constant time. But here when to pre-process or to prepare the data structures that will store the new integers, and I can say that, its time complexity is the big O(n). And we have an extra space here, which is big O(n)(2). It's okay for the memory here, I think. It will not exceed the memory. And it's okay for the query here is a constant time. How to build this prefix sum array? We have our original array here, A. If we take here the size 20 and just the 2 queries, for example, here, the original array is, as you see, 20, 22, 3, -1, etc. The prefix sum array, we're going to build a new array of size n plus 1. And we're going to put in the first cell here at index 0 the value 0, and we're going to use this formula. A new array I called here pre as a prefix. Prefix of I is equal to prefix with I -1 plus the original array, the value of the original array at index -1, 2. Let's see this, for example. At index 1 here of the prefix array is equal to prefix array -1 index 0, which is 0 here, plus a -1, which is a of 0 here, which is 22. So the sum will be 20 in this case. Pre of 2, prefix of 2 here, compute this one, is equal to the precedent sum, which is the previous sum, which is 22, and plus this value, which is at A1. So 22 plus 3 is 25. Let's continue with the third one here, which is 25 plus -1, 24. Which means that if we want to continue a little bit here, for example, if we take the sum at pre of 6, which is the sum? The sum is the sum of the of the element and the original array from index 0 to index 5. If we compute them, uh, 22 plus 3, 22 plus 3 plus minus 1, minus 1 plus 5 plus 22 plus 10, as you see, is equal to 61. So the sum at this point is the sum of the original array from 0 to this point minus 1. Let's continue the sum, building the prefix sum array using the formula. As you see, the sum is accumulated here. Okay. This is very simple to build it or to use this array. Of course, because we have a static range sum query, we're going to build this array just once in big O n time complexity, and we're going to use this array to get the query, the sum between two bounds, left and right, the left bound and the right bound, in just constant time, big O1. Let's see how to compute the prefix or to compute the sum between two bounds, left and right. It's kind of proof of correctness here. We have, as we see in this formula here, we have prefix I is equal to prefix I minus 1 plus A at the value at A minus 1, index minus 1 of the original array, which is equal, if we take this quantity here, which equal to this one. Prefix I minus 1 is equal to, of course, if I follow this formula, is equal to prefix I minus 2 plus A at I minus 2 plus this one. And we will continue like this. It's very simple to understand. It's not a complex math here. We reach this point. Prefix at 0 is equal to A at 0 plus A at I minus 2 plus A at I minus 1, which is this quantity is the sum from k equals 0 to I minus 1 of A at k. The summation from 0 to A minus 1, if we can tell this, plus prefix of 0. And we know that prefix of 0 is equal to 0. So the prefix of I is equal the sum from 0 to I minus 1 of AK. K is equal from 0. K go from 0 to I minus 1 of IK. We can say also that prefix of A plus 1 at A plus 1 is equal the summation from K is from 0 to I of AK. We're going to use this formula to prove the correctness of the query. We can say in general, so prefix at a point at index m plus 1 is equal the sum from 0 to m of AI. If you compute the sum on the original array, the sum from left to right, the left bound to a right bound, like this, for example, this one, the sum, we can write it like this. It's the sum from 0 to the right bound minus the sum from 0 to L minus 1. Not L. We want to compute L. So we're going to take the sum from 0 to right on the original array minus, we can say, minus the sum from 0 to L minus 1 on the original array. We can write this like this. The sum from L to R in the original array is equal to sum from 0 to R in the original array minus the sum from 0 to L minus 1 in the original array. Using this formula, we can say that equal to the prefix, and the prefix from R plus 1, right, plus 1, using this formula. This one, using this formula, give me this, minus this one, using also this formula, gives me this. So we can reduce, if the sum is pre-computed, this is we call the pre-processing operation. If the sum is pre-computed in the prefix array, instead of run over all these cells, we can just access to the cell in the prefix array at index R plus 1 minus the cell at index L in the prefix sum array at index L. So as you know, the accessing, the time complexity of the accessing to an array at an index is constant time. So we can write this pseudocode. Build the prefix sum array in O1. Then for each query, initialize the sum S at 20. Then sum from L to R is equal to the prefix is equal to the prefix value or the prefix or the sum in the prefix array at index R plus 1 minus the value in the prefix array at index L, which is in O1. So the time complexity of the whole code is O big OQ. There is no times N here, but just the number of query. And the space complexity is O1. Let's code it. Let's change. Okay, let's get a new file here. Okay, I'm sorry for this. I forget to make a new file here. Let's take all this code to this file. Of course, this function will change here. Let's call it just transit query using prefix sum. Of course, the parameter will change. The parameters will change here. We don't see what we're gonna put here. Okay, let's build the original array, but here we can do better. We can omit. We can change this input array to our prefix array, because we wrote the entire code here. That is it's not a function to complete. So let's leave it. So we can say that pre here is time plus 1, and let's initialize to 0. Okay, I forget the loop for this initialize. It's equal to 0, and then okay, in the loop here, when we read in the value by value, instead to put the values in the input array, let's put it on the prefix array. We're gonna first read the value from the keyboard, then the prefix of I, it is not 0 here, to n. Okay, because is the size in n plus 1, so we have to reach n error. We can put like this. It's the same here. I prefer this one. Is equal to what here? Is equal to pre I minus 1 plus b. Then we have, I think here we will not reduce 1 from the left bound and the right bound. And 3 here. First, s is equal to 0. Then, as we have said, prefix at index r plus 1, or just return this value, this expression, the value of this expression. I think all is done. It's not here. Okay, let's try it in this test case first. Failed. Y is failed here. Let's see it here. P of I is equal to plus B. Let's display this array. Let's see it. From 0 to n. Let's display it. Okay. To see the values here in the array. Okay. First we have 0, then 3, then 5, then 9, then 14, 15. So I think it's correct. The prefix array is correct. What's going on here? I think I have to reduce this. Yes, I have to reduce it because we deal to fit with this formula. This formula, as we have seen here, the original array from 0, and the prefix array is from 0 also from to n plus 1. Okay, let's submit it. This one, range queries. Okay. Wrong answer. We have a wrong answer here. Why did we wrong answer? I think, okay, I think we have to change into long here. It's because long, place all, because I have to return here and make it int main. I think it's okay for now. Okay, let's submit it again, because as you see, we think we exceed the int type here. We exceed the value, the limit of the integer type. Let's submit it again. Okay. Sorry for this, guys. It happens. Where is the file? The file is here. Let's submit again. Okay. As you see, the code is accepted. So here, let's using the prefix sum array when we have a static range static range sum queries. Sorry, we can pre-process the computation here by computing the sums in the new array and perform the queries in castle time. Let's remind for the following things I'm going to say here. Don't forget, guys, that we deal with static range queries, which means there is no updates in the original array. If there are updates in the original array, we cannot use this technique, the prefix sum array, because the time complexity will change here. Will not be constant time if we have updates. But here we don't have updates, we can use this. It's time to practice now. I suggest these two problems. The first one is the range XR queries from the same online judge here, this one. And the second one is the range sum queries from lead code, the problem number 303. You can see it. Problem number 303. Okay. This one. This problem here. Of course, guys, try to use the prefix sum array technique to solve these two problems. Enjoy, guys, and thank you for watching.